good day, Algebra. We are covering CO56, which, like I said moments ago, is quite literally the opposite of PO55. In PO55, here's what happened. I gave you an equation, such as y equals x squared plus 15x plus 56. We set y equal to 0, so we could solve it. This method of an equation, ax squared plus bx plus c, we would factor it. I skipped all the work that went into the factoring, but ultimately, we would get x plus 7 times x plus 8. We'd look for what value for x made each set equal to 0, and that's where we came up with the x-intercepts of -7 and -8. Okay? That's what we did yesterday, the day before, past couple days. Now in 56, I'm giving you the x-intercepts, and you're going back to the original equation. Okay? So the objective today is to write an equation knowing the x-intercepts, piggybacking off of finding the x-intercepts from an equation. And so our first step, if I tell you that the x-intercepts are -7 and -8, we're going to go back to the parentheses that those solutions would have come from, right? If an x-intercept is -7, that means it came from the expression x plus 7, right? Because -7 is the value that would make that equal 0. Okay? If an x-intercept is -8, that means it would have come from the expression x plus 8, because -8 is the value for x that would have made that equal 0. You see how this is exactly the opposite of yesterday? Right? Who's shaking their head no? I saw a no somewhere. Anybody? Good? No, you don't see it? Okay. Questions or no? Okay, so now once we get here to our parentheses, going back to the original equation, how do we get from a set of binomials to a quadratic equation to a trinomial equation? You got three options. I've listed two of them: crab claw, foil, or what else could you do? You could box it. Okay. That brings you to the original x squared plus 15x plus 56. We replace 0 with a y to make it officially a graphable quadratic equation, and we're done. Okay? So yesterday's skill was going from the equation to the x-intercepts. Today's skill is going from the x-intercepts back to that original equation. Right? And really the key to this is getting these two steps down here. Knowing what the x-intercepts are, what parentheses did those come from? Okay? So let's practice a little bit. X equals 4 and x equals 7. If this is the x-intercept, what expression would that have come from? Such that positive 4 would have been the value that made that equal 0. Connor? X minus 4, right? If you had this in yesterday's objective, my question then is, okay, so the answer is, what value for x makes this equals 0? You'd have said 4, and that would have been the x-intercept, right? So today we're saying, where did this come from? Noah, what expression would give us an x-intercept of positive 7? Sorry? Well, x plus 7 will give us -7, right? Because the whole point is what makes that expression equal to 0. So 7 made this expression equal to 0. Therefore, the expression was x minus 7. Basically, you're taking the opposite of what the given x-intercept is, right? X is positive 4 in the expression x minus 4. X is positive 7 in the expression x minus 7. Okay? And then to get back to our original quadratic equation, here's where you get to box, foil, crab claw, whatever you want to do. We haven't done foil in quite some time here. So let's do old man foil. Okay. First terms, x times x is x squared. Outside terms, x times -7, -7x. Inside terms, -4 times x, -4x. And last terms, -4 times -7, positive 28. Hey, old man, right? And then we would combine where we can these x terms. -7x minus 4x is -11x. And here's our original quadratic P equation. Y equals x squared minus 11x plus 48. Right. Questions on that? The objective where we foiled crab claw box, I believe, was 48, maybe? Okay, so if you need to review that, you can look back at PO48. That's where you first covered multiplying binomials. The next one, 3/4 and -9/4. Right? Remember when we got fraction answers yesterday, right? We had those equations in ax plus b form, and our solution was that negative b over a. So if our x-intercept is 3/4, what expression would that have come from? Our numerator, that 3, that came from the constant here, right? Our denominator, that a, that would have been our coefficient, but how's it going to look in an expression? Lila.
4x minus 3.
Good, 4x minus 3, right? Because to get positive 3/4, we would have taken the opposite of this negative 3, which is positive 3, and then divide by our coefficient 4 to give us positive 3/4. Okay? How about -9/4? What expression would that have come from originally? Maggie?
4x.
Very good. 4x plus 9, right? Because the opposite of that 9 would make that negative. That's our numerator. That's our constant, that opposite. And then the coefficient of 4. Okay? And then just like the previous one, to get it back to our original equation, foil, crab claw, box. We foiled the last one. Let's crab claw this one. We're taking 4x times 4x, which is 16x squared. 4x times 9, which is 36x. Now we go to our -3 here. -3 times 4x is a -12x. And -3 times 9 is a -27. Crab claw. Okay. Again, combine those x terms. And we get 16x squared plus 24x minus 27 as our original equation. Okay. So typically the challenging part of this is going from the x-intercepts to the parentheses. But if you kind of look back to yesterday and say, okay, here are my parentheses, how did I get those x-intercepts? And just do the opposite today, that would be what I would do. X equals -10 and x equals 0. What type of equation do we know this is going to be here? Based on the x-intercepts that we have here, it'll be quadratic, yes. But is it going to be ax squared plus c, ax squared plus bx, or ax squared plus bx plus c? Remember, there were those 3 types. This one's got a quirk. Lila.
Ax squared plus bx.
And what tells you that?
One of the intercepts is 0.
Yeah, excellent. Right? When we have that x-intercept of 0, we know it's going to be in this form, y equals ax squared plus bx. And if you look back to our examples of equations like that, okay, where did this x equals 0 come from? Where did the x-intercept of 0 come from when we worked on pulling out the greatest common factor, finding the x-intercepts? What part of that process gave us x equals 0? Remember? Okay. Well, what we did, I'll just put up a random example here. You don't have to write it down if you don't want to. But if we had 12x squared plus 10x equals 0, our first step would be to pull out the greatest common factor, right? What's the greatest common factor of 12x squared and 10x? 2x, right? Have that 2 and that x. And then left in our parentheses would have been a 6x plus 5. And then that x equals 0 came from that GCF out in front, right? That was the freebie, because this expression, what makes 2x equals 0, or what makes 10x equals 0, or whatever this is, x will always have to be 0. So if we're given an x-intercept of 0, we know we're going to have one set of parentheses with what on the outside? An x term, right? At the very least, we always at the very least, you can always pull out an x of ax squared plus bx. So in this case, seeing that one x-intercept is 0, we know it's going to be in that form. We really only have one set of parentheses to deal with. Our other coefficients, where that 0 comes from, is just going to be an x. And then what goes into the parentheses? That would give us negative 10 as an x-intercept. Someone new today. What expression would negative 10 be the solutions used to make it 0? Lauren. X plus 10. Okay? To get the x-intercepts of 0 and negative 10, we know it's in this in this form. That value of 0 comes from that x term out in front. The negative 10 comes from what's inside of the parentheses. And so we don't have to FOIL crab claw box this. In this case, we would just distribute that x, and we get y equals x squared plus 10x as our original equation. Questions on this? Okay. Let's look at some more. I think it's just a one-pager from here on out. Yes, indeed. All right. Let's look at 3 and 6. What are the sets of parentheses? What expressions would positive 3 and positive 6 come from? Right? If 3 and 6 are our x-intercepts, that means they came from parentheses. What expressions would they have had come from? Aiden.
X minus 3 and X minus 6.
Excellent. X minus 3 and X minus 6. Again, just kind of the opposite, right? And then what would you do to this to get the original equation? Who are our old man FOIL fans? Ooh, none. Don't tell him. Crab claw fans. Boxing fans. I don't know what I'm doing fans. That's okay. Okay? That's okay. To multiply binomials together, you've got those 3 options. We went through old man FOIL. We went through crab claw. Those are in the first page there. The third method, the boxing method, perhaps you remember this, right? We have a 2 by 2 expression. So we're going to make a box. That's 2 by 2. X and negative 3 would go on the top. X and negative 6 down the side. You can switch those. X minus 6 could go up top. It doesn't make a difference. Right? But then in each square here is the product of what's on the outside. X times x is x squared. X times negative 3 is a negative 3x. Negative 6 times x is a negative 6x. And negative 6 times negative 3 is a positive 18. Right? And then just like in FOIL, just like in crab claw, these x terms can be combined. They show up diagonally there. Negative 6x and negative 3x is negative 9x. So we have x squared minus 9x plus 18 as our original quadratic expression. Okay? Next one, negative 8 and positive 8. What do you know about the quadratic equation that these x-intercepts come from? What do you know? John.
6 plus 3. I mean, X plus 3. No, X
We're on the second one here.
Oh, X minus 3.
We're on negative 8 and positive 8.
Oh,
There's not going to be any 3's involved. Look
I
at
mean,
the equation.
I mean 8. X minus 8.
Okay, so one will be an x plus 8. One will be an x minus 8. But what do we know our final equation is going to look like based on the x-intercepts we have here? And this goes back to those quirks, right? Each type of equation has a method, and it's got kind of a hint. Yes?
It'll be an ax plus c form.
It'll be ax squared plus c form because negative 8 and positive 8 are opposites, right? Opposites. And in this form, your 2 answers will always be opposites, okay? It's really going to help to know these tricks as we go along. Right? They're in your binder for you. They're at key points. We talked about them. Recognizing and knowing what you're going for is going to help check, make sure you're correct, right? Also just better your understanding of all this stuff. So x plus 8 and x minus 8, we can box, foil, crab claw, whatever you want to do. Anna, would you like to foil, crab claw, or box? Pick one. Okay. Gigi, foil, crab claw, or box? Excellent choice. Really could not say a wrong answer there. So we'll make our box. X plus 8 goes across the top. X minus 8 down the side. That could switch. You can go the other way. It's fine. Morgan. Not now. We're already halfway through. We'll do crab claw the next one. X squared in the top left corner. X times x. X times positive 8 is 8x. X times negative 8 is negative 8x. And then 8 times negative 8 is negative 64. And what happens with our x terms here, our positive 8x and negative 8x? Noah, you look like you have a question. You sure? Okay. What happens with our 8x and negative 8x? Connor? They cancel out. Right? 8x minus 8x, 0. They're gone. Which means we only have an x squared term and a constant. Just like we're supposed to, because we recognize at the beginning that those two values are opposites. And so those x terms are going to cancel out. Right? Do this one on your own. Morgan requests that you crab claw, but really if you want to use either of the other two methods, that's fine. She won't know. We'll do crab claw up here though when we go over it again. Okay? So take 30, 45 seconds and write the original equation that would have x-intercepts of -2 and -9. Remember to get you started here. -2 would come from the expression x plus 2. -9 would come from the expression x plus 9. Right? So if you got that far, then you kind of got the new part for today. Because old man foil, crab claw boxing, that's old stuff. This is the new stuff. Getting from this x-intercept to the expression. And since -2 is the x-intercept, it came from the expression x plus 2. That's what makes it equal to 0. Crab clawing this. X times x is x squared. X times 9 is a positive 9x. 2 times x is a positive 2x. And 2 times 9 is a positive 18. Crab claw. Okay? Combine the x terms. 9x and 2x make 11x. And y equals x squared plus 11x plus 18. Okay? Hopefully most of you were successful. If not, anyone want to ask a question where they went wrong? We can talk about this more. Anyone? No? Okay. So obviously kind of the more difficult piece is when we've got fractions, just because you know what expressions did those come from. So let's look at -3/10 and -1/4, the third one in this row here. X equals -3/10 and -1/4. Okay. The numerator of that fraction, right? In the parentheses, that was the constant. And the denominator of that fraction in the expression in the parentheses was the coefficient. Using kind of the shortcut we talked about yesterday, negative b over a, those pieces came from here. So you can kind of fill this in. If you know that the denominator is the coefficients, that means that we're going to start with a 10x here. Right? And then what would our second set of parentheses start with? Second will start with a 4x. Yeah? Good. And then that constant is the opposite of the numerator. So if our numerator is at -3, we do need to include that sign, -3, then in our parentheses it was a, anybody? Where's on the first set? +3, yes, +3, right? Because if that was the expression that you had, to get to the x-intercept, you take the opposite of 3, -3, divided by coefficient 10, -3/10. Right? The second one is a -1/4, so it's going to be 4x plus 1 in our parentheses. Because to get that -1/4, it's the opposite of your constant, -1 divided by coefficient 4. And then from here, FOIL, crab claw, box, what do you want to do to get to the original expression? Okay. Is there another one you'd like to at least get to the parentheses step to make sure that you kind of get that process down? Leah. 6/5 and 0. Okay. So again, this is one of those where we see that 0 there, right? So we think, what type of equation is this going to be? We know it's going to be ax squared plus bx, because in that type, one x-intercept will always be 0. And we think about what that solving process is, and we remember that we've got one set of parentheses with a term on the outside. And for our purposes here, if x equals 0, that 0 came from the x on the outside. Right? And then what would 6/5 as an x-intercept look like coming from an expression here? Something I haven't heard from yet today. +6/5. What would that look like in the expression? I've heard from you. Thank you. Sasha. Excellent. Denominators are coefficients. So start with 5x, and the opposite of our numerator, since it's +6/5, it's going to be 5x minus 6. And then no FOIL, crab clawing, boxing required. We simply distribute into our parentheses if we only have one term on the outside. Okay? Questions on this? The opposites of PO55, CO56. Okay. Homework for tomorrow is this. You've got con due tonight as well. Don't forget about that. I'm here after school until 3:30 for health and for retakes. Math packet was due today, now due Monday. I extended the date, and I will try and get those back to you ASAP.